Hello, I'm Will. Welcome to ResearchPod. The built world around us is one that can feel rigid and unyielding, from the glass and steel of modern design to the centuries of brick and stone that came before. However, to borrow a phrase, no building is an island. Those bricks, that steel, the street it sits on, they all came from somewhere, and we can plan ahead for what comes next for those materials and their shared space. Lara Katscher from Werner Sobek Green Technologies joins us today to talk about building projects that capture the trends and technologies at the forefront of engineering, and even capture carbon, to put architecture and design at the heart of climate research. Joining me from Werner Sobek offices in Stuttgart is Lara Katscher. Lara, hello.
Thank you for having me.
Could you tell us a bit about your work, what you do in the company, and what kind of role you have across the green solutions thinking and the future mindedness of Werner Sobek?
When I actually started my master's degree in Frankfurt, and I applied to working part-time as a student at Werner Sobek in the Frankfurt office, as I was just quite impressed by their vision of combining excellent engineering with design and then also their sustainability approaches. So I thought I'll give that a try, and I got in and haven't left since, actually. So I now work in Stuttgart, and I'm managing director of Werner Sobek Green Technologies, part of the Werner Sobek Group, and we focus on sustainability, on MEP engineering, and on building physics. I always had an interest for the built environment. That's it's all around us every day. And what I personally really like is challenges. Well, to be quite honest, the greatest challenge that we face today is climate change and balancing the carbon budget. So I thought to combine that challenge with an industry that I felt passionate about is what I would want to do. And so far, we're still in the process of tackling that challenge. So I haven't got on board yet. And Werner Sobek as a company was quite early on actually involved in those topics. Basically, from the first start that I started working there, it was always an issue and always a topic that we addressed, even though it wasn't that much in the public knowledge at that point.
This is a big challenge, spanning, decades worth of research, spanning the entire globe. In terms of building design and industry, how responsive can design be to that changing environment and the climate change that's part of that?
Recent public interest is coming from the spike in energy prices. This is what fueled it, and this is where it's come from, that sort of, as some people see, very suddenly. And this is obviously very positive from a climate perspective, that the society is now taking energy efficiency more seriously. And this will certainly be helpful for tackling our carbon problem. However, we have to also use this as an opportunity, sort of as a catalyst to accelerate development and progress. And whilst it has arisen from the high energy prices, the issue is actually far more important. It's actually important completely independent of energy prices. Even if the energy prices drop again, that doesn't mean that this becomes irrelevant. Mm-hmm. And energy efficiency alone is also not tackling the underlying issue that has caused climate change, which is the degradation of a natural environment and our need to be more efficient with the energy and the resources that we use. And this is not just, as I said, not just about the energy, but also looking at the resources. And the problem that we've got there is that we do not include the true value that the environment provides us into the costs of the goods that we produce and that we consume. So in the long term, we must seek to make the resources we do consume go further if we wish to maintain affordable living. It's quite a complex topic. It's very hard to grasp, actually, because the energy efficiency itself is quite a big issue right now. But we're also looking at the same time, there's huge discussions going on about using more wind energy, more solar energy. So we're looking at rising the percentage of renewable energies, and we're pushing towards 100% renewable energies electricity. What happens when we get there? So the energy efficiency is then obviously still an issue, because even renewable energies is not going to be for free. You're still going to have to pay the bills. But actually, in regarding to the emissions, it's then actually not relevant at all anymore. So from an emissions perspective, energy efficiency is then actually not a big issue anymore. So rather than just focusing on energy efficiency now, because it's at the moment the hot topic, we need to look at the same time also at the grey emissions that result from the material production.
You say the grey emissions are embodied emissions. They are, I suppose, to the legacy of the carbon that is involved in the production of any new facility or building. That raises the question of access to new technology, because that new technology has to be built, has to be deployed, built into the grid and integrated. Do you see that there is any disparity in access to who is getting to use that renewable energy, groups that are being, left out of advances or regeneration or new technology and stuck with the bad old ways?
Well, the issue with new technology is quite naturally, as it always is, sort of in every industry. It tends to be more expensive at the beginning than just sticking to the old technology, which is in like the mass production already.
Mm-hmm.
So obviously, like there is some limitation to maybe one or the other not being able to afford any new technologies that they might want to put into their building or that they might to use. New technologies that are very commonly used these days, but which are actually not that new anymore, is heat pumps, which is like the new trend in, the new heating system that is used in most of the projects and most of the buildings. And what obviously the energy prices, what we talked about just before, like the spike in the energy prices has meant is that there's a huge run on those technologies because they've been on the market for a while, so they've actually become more affordable.
Mm-hmm.
But the industry wasn't ready for that massive run. So there is a shortage in supply at the moment. So it's actually not that easy to get to it. And then as the market is sometimes, I guess that's obviously also different from country to country and also from district to district, is that then whilst the technology might actually be cheaper already or might have decreased in price again, once there is more demand than there is available, the prices do rise again. So this is a bit of an issue at the moment, but in overall, that trend is quite good. In Germany, we've got a very big government funding program for energy efficiency buildings. So we've had that for a couple of years now, and over the last years, the fund significantly changed. So the goals have been set for like the highest energy efficiency standards, and if you want funding, there are now also specific requirements actually for the heating systems, resulting even more in a push towards electricity-based energy concept with heat pumps and solar panels. So it's that, as well as the rising prices on gas and oil and electricity, that has given that a massive push, which is generally a good development, I think. Probably the other thing that needs to be considered, though, is that there's like when we just take the example of heat pumps, there's quite a wide variety of heat pumps, and that it needs expert project specific planning for installing those heat pumps for them then to work in the most efficient way possible. So it's not as easy as just buying more wood to throw into the oven, but it actually requires expert planning there, which is something that needs to be considered because it's not like any heat pump is necessarily then efficient. It needs to be used in the right way. It needs to be put up in the right setting.
Let's pick out some of the elements in particular, and we can talk through the solutions that there are, starting with insulation, which in the UK has been a big topic. It's, a big topic every winter, but the last few winters have been notably extreme. And there is a push for this refit revolution, they call it, that insulation could be a silver bullet to solve all your problems, make the winters more tolerable and the summers more manageable. Is that the case, or is there a lot more nuance that we're not getting?
When talking about insulation in a house, there's two aspects that need to be considered. So firstly, it's the reduction of the operational energy by means of a better U value of the building envelope. And this is the reason why most people want to insulate their buildings. This is what we're looking at. This is what we're talking about mostly. But secondly, there's also the usage of raw materials. These days, insulation products are rarely made out of recycled materials. So we're talking about mostly raw materials that are being used to insulate our houses. So this therefore actually means that more insulation reduces the U value, hence it reduces the operational energy, but at the same time, more materials are used, hence more grey emissions. So it is therefore actually quite a fine line between the two, and both need to be considered on a case-by-case basis to then evaluate them against each other and find out the perfect solution. On that note, we did a very extensive study on building renovations because, well, I guess we all know that newly highly efficient buildings are only a very small part of the solution, right? The majority we have to achieve is through refurbishment. And with refurbishment, the problem is that there's rarely standardized solutions and more customized solutions required. So we did a study for the city of Hamburg, where we looked at different building types and different renovation scenarios. And rather than just looking at the energy efficiency, we also looked at further sustainability criteria, such as grey emissions and the material usage of raw materials, as it is about optimization between the energy saving, the resource consumption, and the emission reduction to then actually find the ideal refurbishment scenario. If you look at a portfolio of existing buildings, it is, I guess, quite obvious that the biggest improvements that you can make is if you start with the oldest buildings that have the poorest initial energy conditions. The improvements that you can do, obviously, considerably higher than starting with newer buildings. And in order to achieve, therefore, like the most efficient ratio of gray emissions, where you use new materials such as insulation, but also to reduce the operational emissions saved, the depth of the refurbishment is decisive. So how much do you do to refurbish the building? How much insulation do you use? What's the balance that you need to achieve between how much do you need to put in, how do you refurbish the building, to then the operational emissions being saved? In this case, we've come to the conclusion that the refurbishment measures that need to be taken should only go to the extent of where it is then possible to allow a new efficient design of the energy supply system, which tend to be, like, if we go back to heat pumps, tend to be based on low temperature systems, for that to be able to go in, because those low temperature systems are very difficult to put in old buildings which are not insulated, meaning there needs to be a certain insulation standard to the building for those systems to work. So this is actually the result that we came to, is that this should be achieved, but then actually not any more insulation than what's necessary to put in those low temperature systems. Because from that point onwards, it's the grey emissions that result from putting more insulation on the outside of the buildings to be considered worth from an emissions perspective, then the operational energies that can then be saved even further during the operation of the building. So this is what we should actually aim for, and that's what we need to look at in very specific. How much insulation do we need, but also when is insulation too much? Like, when are we at the point where the saving in the operational emissions, or the further saving in operational emissions, is not worth it valued against the additional grey emissions that result from using more insulation? When taking into account the limited material resources and the grey emissions resulting from the refurbishment measures, a premature refurbishment of intact building components should be absolutely avoided. So the latter is actually quite relevant if we look back at the high energy prices at the moment and the push towards energy efficiency, because what this does is sometimes that it leads to very, let's call it, impulsive buys. For instance, when windows are replaced way ahead of the end of their lifetime for immediate energy efficiency reasons, but then actually not taking the grey emissions into account at all. So if you look at that as a whole from like all angles, you would look at what is the energy efficiency releases that leads to, but at the same time, also what are the grey emissions caused by it? And then you need to weight them against each other, and you would then probably get to the result that it is better to maybe wait another 5 years or maybe another 10 years, because at that instance, it would maybe actually be too early, and the energy efficiency savings are actually not worth the grey emissions that are caused by replacing components way ahead of their lifetime.
This touches on some other topics that we covered in a previous interview, looking at life cycle inventory, I think was the phrase there.
Yes, as well. That's also part of the life cycle analysis, because in the life cycle analysis, you do look at components or at buildings over the lifetime, and it does also take the lifetime of the components into account. So if you start extracting them earlier from the building, or if you start replacing them earlier, then that changes if you've done an initial life cycle analysis, then that would obviously change that, because the life cycle analysis is always based on that the components are used throughout their entire lifetime.
Mm-hmm. And leads also into the work that I've seen at a building called The Q, I believe, which has won a couple of awards in the last couple of years. Could you tell us about what's going into that as a case study?
Yeah, so the Q project, it's a very big renovation project, but actually it started off with it having two different scenarios that we looked at from a carbon perspective. And one of the scenarios was a partial demolition. There was obviously some things that would have to be changed, but mostly refurbishment of the project. And the second scenario was a complete demolition, and then a new building of the project. And we looked at that, just looking at the grey emissions, what would that mean for the emissions resulting from those two scenarios? And as you might guess, the renovation scenario is, in regards to the carbon footprint and in regards to the grey emissions, much preferred to the new building. Unfortunately, in most cases, I mean, that is always the case, that renovation should be preferred to a new building, but unfortunately it is mostly not selected because it is so much easier to build a new building. It is actually tends to be cheaper. You can do what you want. You're not restricted, or you're not as much restricted by, like, for instance, ceiling heights, etc. So it was a big success in that project that actually then the decision was actually made to refurbishing the project. It's progressing quite well. It's under construction, and as it is with refurbishment projects, there's always new topics and challenges arriving during construction. So it doesn't stop once the workers are on site. It actually keeps continuing. There's new topics coming up every day. But we quite like those challenges, and we're really happy that the developer in that case chose a refurbishment scenario.
When it does come to the new buildings, then the new technologies that can go into not just energy sourcing and energy management in them, but down to the construction materials. I understand that the NEST initiative of having everything to be either reusable, recyclable, or compostable has led to certain innovations like mushroom paneling or recycled bricks. Do you see there being any avenues for new development or new research there that people might not have ever imagined? Because when I think of a mushroom house, it frankly gives me creepy crawlies. Don't like the idea of that at all.
Well, I mean, the project that you just mentioned, it's an experimental unit. Well, it's called Urban Mining and Recycling, and it's part of a research building in Switzerland. So there has been obviously opportunities to try out new materials that are not possible in that way in a very normal construction, in a normal project, because as it is with research projects, you've got a lot more freedom. But the project itself has gained a lot of attention, which is what we're quite happy about, because it gets people interested in new materials. You've already mentioned a few. There's also a paneling made from shredded drink cartons, for instance, which looks quite interesting, quite colorful, because actually it's only like there's actually nothing added to it. It's just there's also already some glue in the drink cartons themselves. So they've basically just been pressed into a panel. Well, it's an example of downcycling. You're not going to be able to do anything with it afterwards, but certainly a far better option than just putting it straight into landfill. Another material that we used was a denim insulation product made from old jeans, and it is also common knowledge that the fashion industry also has a huge problem with waste being generated with the fast fashion these days. So this was also a very interesting way of using something that's there and that there's a lot available from it, using it in a different way. With actually applying it to our current project, we do face some difficulties because it's very, very strict in regards to the standards and the guidelines that we have to fulfill in the Western world or in Europe specifically. So there is some boundaries that we face in trying to get those new products into the projects, but we feel like it's still important to have those research projects to start people thinking about it, and then gradually they'll make their way into the day-to-day business.
And there was another case study that's kind of stuck in my mind as an example of a changing attitude, not just towards building and sustainability, but living, urban design, and city management even. The Kalver Passage. Am I saying that right? Kalver?
Well, you would call it Kalver Passage in German, but I guess from an
Kalver.
English perspective, that is fine. Yeah. So, well, factors like vegetation, water surfaces, materials, shading tend to be only part of the urban planning level, so that we look at on a city basis. But they should actually also be taken into account when designing a building, because every building can both worsen but also improve the urban climate significantly. And if we look at the number of buildings that we've got in the cities, we can actually do quite a fair bit with improving the urban climate if we also take that down to the building level. So the Kalver Passage in Stuttgart is, well, if it stands out due to its green facade, and it has therefore quite an effective contribution to the microclimate in the surrounding area. If you ever have a chance, if you're in Stuttgart, walk by or look it up. It's truly a stunning facade. But with looking at that facade, it doesn't only look good, but studies also show that it actually significantly increases the well-being and the quality of life of everyone living and working there. And I felt it personally, just walking past it makes you feel better, especially when the sun is shining. But it's supports the well-being just walking past a green wall, basically. And the green facade obviously provides valuable habitats for various animal species. Obviously, you need to use native plant species when designing it, and it noticeably cools down the facade behind it, as well as the surroundings. Has some positive aspects such as like noise protection, as well as like the acoustics within the city. It's less loud, and it improves the air quality. So there's a lot of advantages of those, and it has a huge impact for the microclimate of the city. But what you obviously also need to talk about is that where there's advantages, there's mostly also disadvantages. Well, the obvious ones is the vegetation needs to be maintained. It obviously needs a continuous water supply, otherwise it doesn't look as nice anymore after a while. But what needs to be discussed most, but which is regularly disregarded, is the additional construction work that's required for the greening. So the construction which holds the plants, hence the resulting grey emissions, they obviously wouldn't be needed if there was no green facade. So the improvement of the microclimate and well-being of the users comes in this case at a cost of higher grey emissions in that case. So the impact of the building's carbon footprint must therefore be quite carefully analysed and placed like in the overall context. So again, it is very important in that case to look at all sort of different aspects, weighing them against each other, and then be able to make an informed decision. Or what do you want to do, and what do you want to achieve? That's the only way really you can develop a truly sustainable project, if you can make those well-informed decisions and if you are aware of the grey emissions that this causes, but if you value them against the other advantages and then make your decision based on that.
Well, so far we've talked largely about urban design and urban building. I wonder if there's any perspective you have on the idea that there is a compromise between where and how to build. In the UK, we have brown belt or green belt developments where disused sites or sites that were supposed to stop the spread of towns are now being candidates for the expanse of homes and industry. The compromise between, well, we have to put people somewhere and we'll make a good enough building effort, or can we do more in the space that we occupy already? Can we make a more sustainable effort within the space to accommodate a growing population, even in the face of however much grey emissions we have to deal with in the meantime?
Well, all alternatives that we have to new development on previously undeveloped land should be explored first. That can be mixed-use developments. It can be increasing density within the cities. So, for instance, in Germany, there's been a push towards, well, we all know the supermarkets, they take up a lot of space, but they're actually only single-story, maybe maximum two-story buildings. So, for instance, increasing density with those, it's actually potential to possibly combine them with residential housing, and it doesn't actually use any more space. But one of the biggest factors is also refurbishment. Like, how can we justify developing a new building, for instance, on Greenland, if there is an empty existing building in the city centre? We can't really justify that. And in the context, we actually need to talk about a very, very unpleasant issue. Both in the UK and in Germany have a huge lack of residential living spaces. So in Germany, for instance, I looked it up, it's 700,000 flats that are needed in 2023. And if you look at the population increase worldwide, it is significant. But if you actually just look at the population increase in Germany or in the UK, it is actually not that significant. So one thing that comes down to is that the housing floor space per person has gone up significantly. We quite like our space. We like to have increased personal space. So whilst it's not a pleasant topic because it affects everyone, but it certainly needs to be addressed when talking about shortage of residential housing. As from a carbon perspective, we simply cannot afford to build at a rate of 700,000 new flats per year.
We've kind of been anchoring all of this through that the climate is going to be changing. It also comes with the risk of more severe weather events that we have to be dealing with: floods, storms, wildfires. So how can a plan for buildings, a plan for design, accommodate extreme scenarios? And can you accommodate all extreme scenarios? Because I know you can put a house on stilts to stop it from getting flooded, but are those stilts then going to be fireproof?
The issue with that is also that resilience and flexibility, it usually comes also at the cost of over-dimensioning, taking big safety factors into account, and therefore also using more materials than are actually needed, resulting in higher grey emissions. But then building the super efficient and sustainable building, which hardly produces any grey emissions, which is then washed away in a flood 10 years later, is suddenly not sustainable anymore, as one aspect of sustainable buildings is certainly that those buildings will be there for a long time and that they can be used for a long time. And so what we do in our project is we do take the effects of climate change to the extent that we can into account, for instance, by doing building simulations, taking future climate scenarios into account. This is on a building level. On a building level, you can account for various factors, but actually also you need to go back one step, because it's actually not just the building design, but also the city and the town planning level. So, for instance, not building on floodplains would certainly help with then not having to prove the buildings against that risk later on. So, as it is with general sustainability, it is hardly ever possible to achieve everything and to find a solution that fits them all, especially if we still want to have something that it's comfortable and nice to live in. Making it resilient against all external factors, but it still being a place of well-being is very tricky to achieve. But the important thing, and what we are always trying to do, is trying to look at all the different aspects, weighing them against each other, so that you're then in the position where you can make informed decisions about what do we want to incorporate into our planning, where are we taking the risks that we might not be proof for the event that happens once in 100 years. But this is something quite important, that it's just having all the facts out there, looking at them. And it's certainly, with these days, it's certainly can't be the standard anymore to just build for the current climate that we live in.
Yes, I believe this is all part of, I'm going to get the pronunciation wrong on this, Kleebau.
Oh, that was correct.
Oh.
Yeah.
The research recommendations put out in Kleebau, which, according to the translation here, is a report looking at the further development and specification of climate-adapted construction, but to bring out some of the highlights of what that report recommends for now and next in construction.
So just quickly what the report is about, like what we've just talked about is climate adaptation, right? How do we make buildings suitable for expected future climate-related hazards and extreme events? In contrast to this, we looked at climate-adapted buildings in the research study Kleebau. So climate-adapted buildings, that means that they take into account the effects of the selected constructions on the local and global environment. At the component level, that means, for instance, the environmental potentials considered, including reducing global warming potential, saving grey energy. And at the property level, this means improvements to the microclimate, rainwater retention, increasing biodiversity, and reducing fine dust. We took at a sample building and looked at all sorts of different scenarios and did some detailed calculations and simulations. And one example that we looked at, for instance, in detail was exemplary roof build-ups. So if you look at a roof, for instance, we did the comparison. If you have a light plastic waterproofing that is used for an insulated roof with exposed roofing ceiling, instead of a conventional bitumen ceiling sheets, which tend to be black or very, very dark, the hours that overheating occurs indoors is actually reduced by 10% in a solid building. If it's a sort of a lighter construction like a wooden building, the temperature indoors, or like the hours of overheating that occurs, is actually decreased even further by 20%. If you then put another gravel layer on top, for instance, the hours of overheating can be reduced even further by another 55%. So what you can see there is that the color chosen just of the waterproofing has a massive impact both on the indoors of the building, but then obviously also on the microclimate, because it doesn't just reduce the temperature indoors, but it also reduces the temperature significantly outdoors. Outdoors, it is actually reduced even further, like just right on top of the roof. It is actually can be reduced by up to 30 Kelvin. So it is quite significant. That's one factor where you just look at the microclimate effects as well as the effects on the climate within the buildings. And then what we also did is that we also looked at the rainwater retention properties as well as the grey emissions of the different structures, because once you have a gravel layer on top of the roof, there's obviously more loads that the structural system needs to calculate in. So it has effects on all sorts of different aspects of the building. And this was just one example of, we took one component of the building, we did similar things with like wall build-ups, and then also looking at how are they resistant against climate hazards. But like looking at one specific component and then evaluating it from all sorts of different aspects, we do come again to the conclusion that it is hardly ever possible to achieve everything. But looking at all of them then puts you in a position where you can then find the perfect solution for that specific project at that specific location.
So can you think of any summary, I guess, for anyone listening to this, for what Werner Sobek Green Technologies is developing, is looking at, is hopeful for in the future, and where they can find out more if they'd like to learn about what you're doing?
Well, we all live and work in buildings. So this is actually a relevant topic for everyone. Even if you don't work in the construction industry, what we've noticed and what we've noticed within the last years is that the user tends to set the demands and the standards. So each and everyone's influence might actually be bigger than you think. We've had a couple of projects where the developer didn't actually have high energy standards or high sustainability standards, and then suddenly turned around when he had the first tenant for the building who requested things, and then suddenly the whole project was turned around in that case. So it's quite a radical change that the construction industry is facing, and we are fully aware that we cannot change everything at once. Nevertheless, that doesn't mean that we should not at least try, and this is what we're trying at Werner Sobek, to push towards more sustainable construction and to have a vision of the city that we all want to live in, which could be made out of a lot of green facades, but then at the same time having a very low carbon footprint from the buildings actually being constructed in those cities, pushing towards refurbishment so that we do still have the green space outside of our cities, which is quite vital to us and to the residents of cities to have that green space to escape to. Even if the green facade is within the city, that doesn't mean that there is no need for forests anymore. So pushing towards the refurbishment and density in the cities itself, rather than developing within the green belts around the cities, is what we should aim for. And I can just urge you as a consumer to start considering the carbon budget of what we do, what we purchase, but also what we build. Set an example and make sure that you get all the information by carrying out life cycle assessments that we talked about, for instance, by doing environmental impact assessments. Just getting informed, even if legislation is not at the point yet where it requires you to do so. It will get there eventually, or at least that's what we think, but it takes a while. And what we need to do now is not wait for legislation to catch up, but actually start looking at those things now in order to then be able to make those informed decisions. And we believe that anyone and everyone, whether you're working in construction industry or not, the influence that you have might actually be a lot bigger than you think. So this is not a reason to not start, to not think about it, but actually go forward with it.
I think it's good to send people away with the notion that they can make change, that they can be the influence that they need to have somewhere to live, not just next year, but in the next 100 years.